So, okay, we've got another question to look at here. We've got a circle which has a centre that's given and it does go through the point shown. We need to show that the circle, firstly, also passes through the point 10, 1. So, what I'm going to do here is start by finding the length of the radius and then creating an equation, then substituting the values given in part A, that's x is 10, y is 1, into the equation that we generate and showing that it works. So let's begin by finding the radius of the circle. So let's say that this is the centre. Let's call that minus 2, 6, because that's given to us. And this is our second point, which is 10, 11. And we're asked to find the radius, which is there, r. So to do that, we just use Pythagoras. The two short sides, the change in the x values is 12 units, the change in the y values is 5 units. So that's a Pythagorean triple, r is 13. Or we can prove that more slowly by saying a squared plus b squared equals c squared. So in this case, 12 squared plus 5 squared equals r squared, so r squared is 169, 144, add 25 is 169, so r is 13. Now we have all the information we require in order to create the equation of the circle. The general equation for any circle is x minus a all squared plus y minus b all squared equals r squared. So, y minus b all squared equals r squared, where a and b are the x and y values of the centre of the point, the centre of the circle. So I get x minus 2, except x minus 2, so x plus 2 all squared, plus y minus 6 all squared equals 13 squared, or 169, whichever you prefer. That is fine. We found the equation of the circle, probably 2 marks generated so far. We now need to show that it also passes through the point 10, 1. So if x equals 10 and y equals 1, that gives us 10 plus 2 squared plus 1 minus 6 squared equals 13 squared, which it does. Therefore, 10, 1 is on the circle. You need to include your conclusion, otherwise you can drop the marks. That's part A completed. Happy, I hope. So for this next part, the tangent to the circle C at the point 10, 11 meets the y-axis at the point P, and the tangent to the circle at point 10, 1 meets the y-axis at Q. Show the distance. Show the distance PQ is 58. Explaining your method clearly. I'm just going to sketch out a little diagram of what we're talking about here. So here's the centre of the circle, which is at minus 2, 6. It's a bit of a weedy diagram. We've got 10, 11 there, and we've got 10, 1 here. And we're asked to show that the tangents to both, well, that's not ideal, is it? Let's try that again. The tangents to both points cross the y-axis at point P and Q. So the y-axis would be there, that's P, and that's Q, and we're asked to demonstrate that that length is 58. Seems that the strategy would be to find the y-intercepts of the two tangents and go from there. So to find the equation of the tangent, we need to know the gradient. And the gradient of the tangent is found by taking the equation of the radius and using the fact that it's at 90 degrees to the radius. So I'm going to start by finding the P, and the radius gradient there is gradient, oh well, close enough. The gradient of the radius there, it goes across 12 squares and up 5, so the gradient of the radius there is 5 over 12. So for the tangent at P, the gradient of that would be minus 12 over 5. Substituting that into the equation y minus y1, etc., I get y minus 11 equals minus 12 over 5 x minus 10. And we can simplify that to y equals minus 12 over 5x minus 24, add the 11, plus 24, so 35. And you can convince yourself of that by doing the expansion more slowly. For Q, rude, the radius gradient, again, is this time it's minus 5 over 12. Radius gradient is minus 5 over 12 because we go across 12 but down 5. So the radius there is going to be minus 5 over 12. So the tangent gradient will be 12 over 5, positive. So y minus 1, because the x value is 1 here this time, equals 12 over 5 x minus 10. Again, we can expand that and get y equals 12 over 5 x, and this time it's going to be minus times by divided by 5 is 2, times by 12, 24, 24 minus 24, add 1 is minus 23. So point Q then up here is at the 0 on the x, minus 23, and point P is at 0 for the x values and plus 35. Since they're directly above each other, we can just add that up, and the distance between them is 58. Now it's not enough to leave it here, we have to make a conclusion. It's obvious that if we look at the values of the intercepts, the difference between them is 58. We need to say that explicitly. Because they're both on the y-axis, we can see that that is 23 add 35, which is 58 as required. That's the value they were looking for.